we see in this analysis that for optimal wealth for the nation, for the whole, we produce inequality. This does not mean that greater inequality is optimal. For example, if we give all our resources to 2 people, we have great inequality. But that isn't producing a bigger pie. That's what makes it challenging. We find that in order to produce a bigger pie so that the wealth of the whole is greater, we end up producing inequality. For example, in the Great Depression and the recent 2007-8 Great Recession, the top 10% hit the same record high levels of the extent to which they got all the money. But the rich don't spend. They save it. They invest. The money doesn't churn around within the economy. So if spenders no longer have money, then businesses have no customers, and the entire system collapses. This is the big question, and it's yet to be resolved. Thoughts and links in comments below. Appreciated. In today's lesson, we use a custom Kelly engine which we implemented in Excel to see what's going on. This lets us see at the individual's level as opposed to just the average, which is what Kelly maximizes. And we're able to play around with the parameters to see how things change. Let's get started. I've implemented a Kelly engine here. So we begin with a pot of $100 or euros or whatever. Every iteration we bet 90% of our pot. And of course I can change this. And our win probability, so the odds that we're going to make money, is 0.5. So we begin with $100. We bet it, or we bet 90% of it, so we bet 90. We have a 50% chance of winning, so if we win, we double our money, so our 90 we'd end up with a pot of 190, or we could lose, since the win probability is only 50%. And if we lost, we'd only have 10. It's a very simple Kelly engine, so I don't stop at 1 cent. It keeps going. It assumes that you can have 1 millionth or 1 billionth of a cent. So, and it continues doing this for 100 iterations. Over here we have 20 imaginary people. So this person has gone through this process of beginning with our pot, so 100 in this case, betting 90% of their money, and they have a 50% chance of winning. So now we update the pot after the first bet, then we do it again, again, and again. So 100 times. And this is how much money we have left. So in this case, it's 6 times 10 to the power minus 40, which is kind of meaningless because, of course, you can't have 10 to the minus 40 money. But you could create a derivative, I suppose. So we have 20 people, each of whom go through that process, starting with a pot, betting 90%, winning 50% chance, repeat 100 times. And this is how much they end up with. This is the average. So we just average the 20 numbers to get this. And finally, this is the median. So we take the median of these 20 numbers. So that means that's the guy who has as many people richer than him as poorer. So that's your kind of typical guy. And this is our graphical representation of the same information. So these are the 20 people, these 20 figures represented graphically. So now we can play around with it. We can comment on what's going on. Firstly, we can see there's one guy up here. Normally there's an axis there. It could be because the numbers are so tiny that it's not showing up. But anyway, so we can see that there's one guy who's got far more money than everyone else. And there's this one person here who has more than these guys, but obviously not doing that great. So the thing here is, if you're betting 90% of your money, that's very near to betting everything. I mean, if you lose once, you lose 90% of your money, and you're going to have to win many times to get back to where you were, to catch up. So that's highly aggressive and dangerous, which is why basically everyone ended up with a fraction of what they began with. They started with 100, now they have nothing. The average is tiny, the median is tiny. So what if they bet a more modest amount? If I just change that to 0.1, they're going to bet 10%. Now it's 50-50 chance of probability of winning. So typically people shouldn't, if you could get lucky, then you'll make money, or you'll end up not. So now here's what actually happened. Well, your average is pretty much the same with what you began. The median is 73. So, that lost money. You began with 100, and after all that work, you or after all that betting, if you count that as work, you ended up with a lower figure. There's a nice spread here. Some people on very little, others with quite a bit more, but not spectacularly so. If the system was such that you had a slight edge, that you're basically, it's a good idea to be investing, then what happens? Well, now the average is 238. Remember, you began with 100, so that's not bad at all. The median, well, that's up from 100, though it's a lot less than the average. The thing is that typically the average, since here you win 55% of the time, so in general it's a good idea to invest, to bet, to take the risk. But the way that that group wins is that some people get lucky. So, you know, this guy ends up with 1,000, multiplied their pot by a factor of 10, this guy by 8. This person was unfortunate. That's a tiny, is that 0? I can look that up here. That's 0. There's one person ended up with 14. So, you know, you end up with a, and this is purely random, but you end up with a random spectrum. So what Kelly tells us, actually Kelly tells us for a 0.55 we should bet 0.1. So this would be the optimal amount. At the same time, it is random, so it's not as if you'll get the same answer every time. If I bet 20%, that's more than what Kelly says we should do. But in this case, we end up with double the money that we got following Kelly. And that's because it is random. Kelly is more, if you repeated this, you know, millions of times, Kelly would be the best. Now, in this case, I'm just using simple Kelly, you know, where if you win, you double your money. So we don't have different odds, because it's a complicated enough system as it is, and adding different odds and stuff, that just kind of makes things more confusing. So again, we see that similar pattern, that the average has gone up a lot. So by taking advantage of where the win probability is greater than a half, by effectively betting in that market, the average, the cake, can expand massively. The median, you could kind of model, say you have a housing bubble. You know, win probability 0.7. It's easy to get money. You just buy a house. It's going up at 20% a year, 30%, whatever. You win. In that kind of a market, well, even betting 20%, you make an absolute fortune. You began with 1,000, it's now 215,000. The median is a lot lower than the average, but even the median has seen a massive increase. So you'd want to be more aggressive. I mean, if you get better, if you get more money back, if you're going to win the bet, solution, bet more. You win again, bet again. Which is exactly the kind of behaviour you saw in the housing bubble, or you see repeatedly. Again, it's dominated by this one spot. So all these people, so we can look at the individuals. They're given on the numbers are given here. So this is unfortunate because it's 0.7. So you should be winning. You began with 100, but they've ended up with 50. If you are betting aggressively, so betting 70% of all your money, if you lose, you need to win several times to recover. So this person has ended up with next to nothing. So loads of people didn't do well at all. But this person, I think person number 3, ended up with a million. So 1,000 billion in, depending on what your definition of a billion is. So this would boost, or did boost, the average to a huge amount. The median, since the median, you have as many people who are richer than you as poorer than you, so the median doesn't get affected by this one person having such a huge amount of money. The median will just look at all the people here and essentially pick the guy who's in the middle. But even that person did very well, nearly treble their money. So I just wanted to look at Kelly, at what's at the next layer, to kind of see that just applying Kelly doesn't guarantee you fortunes. It maximizes the average. So if it's a group of people, that the wealth of that group will be maximized by Kelly, but it doesn't mean that you end up being the person who makes an absolute fortune, since you could just as well be person number 5 who began with $100 and ended up with a fraction of $1, less than a cent. So the question then becomes more a political one. How should we run things? If we run the world this way, well, Kelly will maximize the average wealth of the world. At the same time, if you zoom in at the individual level, you'll have a broad spectrum. You'll end up with that person number 3 who has thousands of billions, while you have all these other people who have next to nothing. The political solution is progressive tax. By having higher tax for the rich, we can redistribute this so that we all benefit from the high average. Since otherwise, why would we play on? Why would we play this game? If we don't redistribute, there's a high chance of having a revolution. That's been the way throughout history. If you're in an economic climate where there isn't opportunity, where the growth, where in general if you invest you lose, well then everyone's a loser. Even if we reduce our betting stake to like 10%, that's not going to change the fact that you're all losing. One more thing. So I had mentioned the idea of using less than Kelly. So the idea there was so if you have a setup where the win probability, in general, you do win, there is an opportunity there. Kelly would say bet 0.1, and that results in an average of 308, so trebling our money, and the median being 180. If I were to bet, or were to have bet, a half of what Kelly said, well, here see the average, it's still higher than 100, but roughly it was 300 the other time. It's only 175. So we're not doing that great. The median is also positive, but the difference between the average and the median is perhaps less. That's what I want to check. So if I make small bets, we see the median and the average are now closer still. So if I only bet 1% of my money, then the median and the average are nearly the same. So by making very small bets, the typical person, which is represented by the median, is doing well. If you just followed Kelly, the average is dominated by one or two very rich people, very lucky people who have the vast bulk of the money, while loads of people do very badly. So you, as a bettor, have a greater chance of being a loser if you bet more. If you bet what Kelly suggests. So one more time, betting only 1% here, no one ended up with less than they began with, but nobody ended up with an absolute fortune. So on the one hand, that's good if you were one of the many who came out badly following Kelly. But on the other hand, it's a case of this whole group remain very poor. This whole group only increased their pot by 12%. While if they'd followed Kelly, they would have trebled their wealth. So, in effect, it just makes sense to basically have a Kelly-like system, since that way we all win. But you've got to have some mechanism so that the select few who end up with an absolute fortune, their wealth is ploughed back in to the system so that we all benefit. And that is done all around us. That's, as I said, a political question, which is in a way beyond the level of this course. But I just wanted to look at the next layer of Kelly so that you can see that, okay, yes, Kelly is maximizing the average, but when it maximizes the average, it is dominated by a handful of people who make an absolute fortune, and that drags the average up, while the median doesn't do that as much.